Hello STAT students and welcome to the video key for Unit 7, quiz review number 2. Let's do this. Much concern has been expressed in recent years regarding the practice of using nitrates as meat preservatives. In one study involving possible effects of these chemicals, bacteria cultures were grown in a medium containing nitrates. The rate of uptake of radio-labeled amino acid was then determined for each culture, yielding the following conservations. Suppose that it's known that the true average uptake for cultures without nitrates is 8,000. Do the data suggest that the addition of nitrates results in a decrease in the true average uptake? What a wordy problem. Okay, well, we can tell the data is numeric because we're given the raw data. So let's get started off with this. Mu is going to be the true average uptake. And we want to see if it's going to decrease. So, do the data suggest nitrates result in, do the data suggest that the addition of nitrates result in a decrease in the true average uptake? So, if the true average without nitrates is 8,000, if we add nitrates, does it go less than 8,000? We want to see. All right, let's check the conditions. All right, condition A is it's a random sample. And let's see. It said in one study involving possible effects of these chemicals. All right, so we actually don't know, so we're just going to assume. Okay, so for normal, n is less than 30. It's not stated as normal, so we have to look at the normality plot. So everybody pause right now, and if you haven't done so already, let's put all of these data values above into your lists of your calculator. All right, and if you forgot how to make your normality plot, I'm going to write the little rules off to the side over here. So remember, you go to second stat plot on your calculator, and then you are going to choose the type, and there's 6 little squares. It is this last one right there. And then you can hit graph. If you don't see anything, remember always hit zoom 9, just like we did back in Unit 5. And then you should get some kind of plot up. And mine looks like this. So I'm going to draw it in right here. I'm going to zoom so it's small. Okay, and so I can say since the normality plot is approximately linear, then we can conclude that this data is approximately normal. So we're good there? All right. Option C is sigma known or unknown. This is a sample, so sigma is unknown. And D, N, which is 15, is less than 10% of that population. Step 5, set an alpha value. We can use 0.05 when in doubt. And step 6, this is going to be a t-test. So in order to get this data, let's go ahead and run those one variable stats over here. X bar is 7,816.267, and S is 999.354. Cool. Step 7. Let's calculate that t-value. T is equal to X bar, 7,816.267 minus mu, which we decided was 8,000, over S, 999.354 divided by the square root of N, which is 15. All right, let's crunch this out and see what we get. All right, got negative 0.712. Let's write this probability statement. Remember, steps 3 and steps 8 should match. So I'm looking at the probability of a t-value being less than negative 7.12. And we can use TCDF. Less than means a lower bound of something large and negative. Negative 0.712, and our degrees of freedom are 14. So let's see what we get. I think it's 0.244. When I compare to alpha of 0.05, this is greater, so we fail to reject the null. All right, so step 9. With a p-value of approximately 24.4%, the data suggests the true average uptake time is 8,000. Oh, not time. Just average uptake. I don't know why I put time, sorry. Is 8,000. Not less. So down here it says, do the data suggest that the addition of nitrates result in a decrease in the average uptake? No. Our data suggests nitrates do not decrease uptake. Cool. 2, in a rural area, only about 30% of the wells that are dried find adequate water at a depth of 100 feet or less. A local man claims to be able to find water by dousing using a forked stick to indicate water. 27 out of 80 of his customers have wells less than 100 feet deep. Does this evidence suggest that the proportion of wells found with depths of 100 feet or less is higher than 30%? All right. We're dealing with pi here. So it gave it to us, luckily. Proportion of wells found with a depth of 100 feet or less. So the true proportion of wells found with depths 100 feet or less. So, only about 30% of the wells that are drilled find adequate water. So we're claiming initially 30%. 27 out of 80 of its customers have wells less than 100 feet deep. Does this evidence suggest that the proportion of wells found with depths of 100 feet or less is higher than 30%? So we're saying greater. All right, let's look at some stuff up here. Our p-value for this problem is 27 out of 80. .3375. There's our p-value for this situation. Check conditions. You know what, and my mistake for calling this p-value. I should have said sample proportion. Random. All right, let's assume. These are kind of wacky problems. Bn, which is 80, times p, which is 0.3, is greater than or equal to 10. 80 times 0.3, 24, we're good. And 80 then times 0.7, is that greater than or equal to 10? Yes, it has to be. And D, 80 is less than 10% of the population. All right, let's choose an alpha value. Doesn't say. When in doubt, 0.05 is fine. This is a one prop z test here. And here's my formula. Z equals p minus pi over the square root of pi times 1 minus pi over n. Okay, this is not being helpful. Anyways, step 7. Okay, z equals 0.3375 minus 0.3 over the square root 0.3 times 0.7 over 80. Let's see what we get for the z value. All right, I got 0.372. So for step 8, they should match. What's the probability of a z-score greater than 0.732? Normal CDF, 0.732, something high like 1,000, 0 and 1. And let's see what we get. 0.232, and this is greater than alpha, so we're failing to reject that null again. So, with a p-value of 23.2%, the data suggests the true proportion of wells found with depths 100 feet or less is 30%. So no, it's not higher, according to our data. All right, let's move on. An inventor has developed a new energy-efficient lawnmower engine. He claims that the engine will run continuously for 5 hours, 300 minutes, on a single gallon of regular gas. Suppose a simple random sample of 50 engines is tested. The engines have run for an average of 295 minutes with a standard deviation of 20 minutes. Test the null hypothesis that the mean runtime is 300 minutes against the alternate that the mean runtime is not. All right, cool. Assume normally distributed. That's nice. All right, number 1. We're dealing with means here, so this is U. And we're looking at the true mean runtime. For this lawnmower. Gave us the null and it gave us the alternate. Oops. We want to know if it's 300 minutes or not. Check the conditions. Is it random? It's stated. Is it normal? Stated. Is sigma known? No, because the standard deviation is from the sample of 50. And 50 is less than 10% of the population. Alpha, I think it told us 0.05. This is a t-test. X bar minus mu, s over the square root of n. All right, for step 7, we have our x bar right here. The end is run for an average of 295 minutes. That's x bar with a standard deviation of 20. That's s. So for step 7, t equals x bar 295 minus 300 over 20 divided by the square root of 50. All right, let's see what this equals. And I got negative 1.76. Remember, for a two-tailed test, if the t-value is negative, then we look less. But we multiply by 2. So we're looking at 2 times t CDF, negative, large number, upper bound, negative 1.768, degrees of freedom, 49. All right, let's see what we get here. When you multiply by 2, you should get 0.083. And when I compare to alpha, it's close, but it's greater. So fail to reject again. With a p-value of 8.3%, the data suggests the true mean runtime is 300 minutes. You work for the Federal Trade Commission. A manufacturer of dish detergent claims that the mean weight of detergent is 3.25 pounds. You take a random sample of 64 containers and calculate the sample mean to be 3.238 pounds with a standard deviation of 0.117 pounds. At the 0.01 level, is the manufacturer correct? All right, this is numeric data. So, you know the drill by now. Mu is equal to the true mean weight of detergent. All right, let's set up the null and the alternate. Always equal, okay. And so it claims to be 3.25 pounds. And you take a sample of 64, let's see. And we want to know if the manufacturer is correct. So maybe if it's not 3.25 pounds. 4, let's check conditions. Condition number 1, is that sample random? And it says random, so that's stated. Condition 2, for numeric data, is it normal? N is greater than 30, so 64 is greater than 30. So by the central limit theorem, the sample is approximately normal. Okay, C, is sigma known? It is not, because that value of 0.117 comes from the sample, that's S, not sigma. And D, 64 is less than 10% of the population, because we're talking about large population tests here. 5, alpha level is chosen for you of 0.01. 6, this is a t-test, so let's write down our formula. T equals x bar minus mu over s divided by the square root of n. Step 7, let's calculate that t-value. X bar is named up here to be 3.238 minus mu, which is 3.25, over standard deviation 0.117 divided by the square root of 64. All right, let's see what we get. All right, so I got negative 0.821. Step 8, let's write our probability statement. Okay, remember for a two-tailed test, that's what it's called when you have a not equal to sign. If your t-value comes out negative, then we're looking less. So we're looking at the probability of t being less than negative 0.821. But since it's two-tailed, we need to multiply it by 2. So remember, when it's not equal to, if this value comes out positive, we look greater, multiply by 2. If it's negative, we look less and multiply by 2. All right, let's use TCDF. Lower bound, something large and negative. Upper bound, negative 0.821. Degrees of freedom are 63. And don't forget to multiply by 2. It's a pretty high p-value of 0.415. And this is bigger than alpha for sure. So we're failing to reject the null. So for step 9, with a p-value of 41.5%, the data suggests the true mean weight of detergent is 3.25 pounds. Cool. So yeah, manufacturer seems to be correct. All right, you guys, for your quiz on Friday, make sure that you do all 9 steps. Don't take any shortcuts. And if you have any questions, make sure to come and ask. See you guys later. Bye.